Welcome to World Explained. Today's episode is about the hidden cost of our digital lives. Most of us think of the internet as something weightless: messages, videos, cloud storage, AI tools, everything happening somewhere else. But the digital world is physical. It runs on electricity, metal, water, concrete, and an enormous global supply chain. Every search, stream, and AI request triggers activity in data centers, networks, and devices. And when you scale that activity across billions of people, the impacts become real. Energy demand, resource extraction, e-waste, and social consequences tied to constant connectivity. To keep this explanation neutral and accurate, we'll separate what is clearly observable from what depends on assumptions. The observable part is simple. Digital services require infrastructure, and infrastructure consumes energy and materials. The assumptions come in when we ask how much impact each activity has, because the answer depends on where the electricity comes from, how efficient the data centers are, how long devices last, and how companies manage recycling and supply chains. Let's start with the hidden engine of the internet: data centers. Whenever you upload a photo, stream a show, join a video call, or use an AI chatbot, your request is processed by servers and facilities designed to run 24/7. These facilities also need cooling, power distribution, backup systems, and network connectivity. In other words, the cloud is a global network of warehouses filled with computers. The first hidden cost is energy. A single digital action might feel tiny, but it isn't free. Servers compute, storage devices read and write data, routers move traffic, and cooling systems remove heat. The energy cost per action can vary massively. Same video can have a very different footprint depending on whether it's delivered efficiently, cached locally, streamed in high resolution, or watched repeatedly by millions. And the same data center can have very different emissions depending on whether its electricity comes from coal, gas, nuclear, hydro, or renewables. This is where it's important to distinguish two ideas: energy use and carbon emissions. The internet can use a lot of electricity without necessarily producing a lot of emissions if the power grid is low carbon. But if a region relies heavily on fossil fuels, then rising digital demand increases emissions. So the digital footprint is not only about technology, it's also about energy systems and geography. Now add AI. Traditional online activity, web browsing, email, streaming already requires huge infrastructure. But modern AI, especially large models, adds a new layer. Training advanced AI systems can require massive computing runs. And running AI at scale also consumes energy, because each request triggers computation and specialized hardware. Here we need to be careful. Not every AI use case is equally expensive. Some tasks are lightweight, others are heavy. AI can sometimes reduce energy use elsewhere by optimizing systems, improving logistics, or reducing waste. So the net effect is complex. But the broad trend is clear. As AI becomes more common, demand for high-performance computing grows. And that increases pressure on electricity supply and data center expansion. Energy is only half of the story. The second hidden cost is materials. Our digital lives depend on physical devices: smartphones, laptops, routers, servers, and the chips inside them. Those chips require a supply chain that begins with mining. Many devices depend on minerals like copper for wiring, lithium for batteries, cobalt and nickel for battery chemistry, rare earth elements for magnets in speakers and motors, and a long list of other inputs used in components, solder displays, and circuit boards. This is where the digital world intersects with geopolitics and environmental impact. Mining and refining can be resource-intensive and environmentally disruptive. It also raises questions of labor standards, local pollution, water use, and community displacement. Supply chains often stretch across multiple countries. Minerals extracted in one region, refined in another, turned into components elsewhere, assembled in large manufacturing hubs, and shipped worldwide. At every stage, there are energy costs, emissions, and political risks. It's tempting to look for a single villain: here one country, one company, one mineral, but the reality is structural. The global economy has chosen a digital lifestyle with frequent hardware upgrades, rapid innovation cycles, and constant growth in data usage. That model produces pressure: more devices, more servers, more batteries, more cables, more construction. And that brings us to the third hidden cost: E-waste. Electronics don't disappear when we replace them. Phones, laptops, and tablets have short replacement cycles in many markets, and a large portion of discarded electronics is not recycled properly. E-waste can contain valuable metals, but it also contains toxic substances. When recycling systems are weak, devices end up in landfills or informal recycling networks where people may be exposed to harmful chemicals. A digital lifestyle is often marketed as clean and modern. The waste stream shows the opposite. It's a physical industrial system with real environmental consequences. Now, let's talk about what makes the hidden cost hard to see. Digital consumption is fragmented. You don't see the data center when you watch a video. You don't see the undersea cables when you send a message. You don't see the power grid when you generate images with AI. That invisibility creates a psychological gap. We treat digital life as weightless, so we consume it without thinking in physical terms. But physical terms matter. For example, the demand for data has exploded because we've shifted from text to images. From images to high-definition video, and now toward AI-generated content. Video is one of the largest drivers of internet traffic. High resolution, autoplay, and endless scrolling increase demand further. The result is not that people are wrong to enjoy digital content, but that design choices made by platforms shape energy use at a global scale. This introduces a social dimension, attention economics. Many digital services are built to maximize engagement. That can mean notifications, infinite scroll, autoplay, recommendation loops, and personalization designed to keep you online longer. The cost is not only electricity, it is time, mental bandwidth, and sometimes mental health. Constant connectivity can reduce downtime, fragment attention, and create pressure to stay available. Again, the impact varies by person, but the mechanism is clear. Business models that monetize attention create incentives to increase usage, and increased usage increases both social and environmental cost. Privacy is another social cost. Digital life generates data trails: location, clicks, habits, preferences, social graphs. This data can be used for personalization and convenience, but it can also be used for manipulation, surveillance, and discrimination. Different societies regulate data differently, and trust varies across platforms and governments. The key point is that free services are often paid for with data, and data becomes a source of power. So far, this can sound bleak, but the reality is more balanced. The digital world also brings enormous benefits. Online communication reduces travel needs for some activities. Remote work can reduce commuting. Digital tools can improve education access, healthcare administration, and economic opportunities. AI can improve efficiency in energy grids, transportation, and industrial processes. So the question isn't, is the digital world bad? The question is, what does it cost? Who pays that cost? And how can we reduce it without losing the benefits? That leads to solutions, and solutions exist at several levels: individual choices, corporate design, and public policy. At the individual level, the goal is not guilt, it's awareness. Small choices can reduce demand, using lower streaming resolution when it doesn't matter. Turning off autoplay, keeping devices longer, repairing instead of replacing, buying refurbished electronics, and managing cloud storage intentionally. These changes won't solve the problem alone, but they reduce the growth rate of demand and signal that consumers value sustainability. However, the biggest levers are systemic. Companies can design services to be more efficient, better compression, smarter caching, and default settings that reduce unnecessary higher resolution streaming. They can also extend device lifetimes through longer software support, repair-friendly design, and modular components. A major part of e-waste is not physical failure, but planned obsolescence, devices becoming slow or unsupported. Extending support cycles changes the footprint dramatically. Data centers can also become cleaner. Many companies pursue renewable energy contracts, more efficient cooling systems, and new architectures that improve performance per watt. But there are trade-offs. Data centers require land, water for certain cooling methods, and grid capacity. The location matters. Putting large data centers in regions with clean power and strong infrastructure can reduce emissions. But it can also create local resource conflicts if water is scarce or if communities resist large industrial builds. Governments have tools too: right to repair laws, recycling standards, e-waste enforcement. transparency requirements for supply chains, and incentives for clean power and efficient infrastructure. Policies can also address labor and environmental standards in mineral supply chains, though enforcement across borders is complicated. Now we return to the title, The Hidden Cost of Our Digital Lives. The cost is not one thing, it's a bundle. It includes energy use and emissions, resource extraction, waste streams, and social effects of attention-driven platforms and surveillance incentives. The cost is hidden because it happens far away from the user, in mines, factories, shipping routes, data centers, and invisible networks. The most useful conclusion is not that we should reject digital life, but that we should treat it like infrastructure, because that's what it is. When you treat the internet like infrastructure, the questions change. How resilient is it? Who controls it? What does it consume? How do we make it efficient? How do we keep it fair? And how do we make sure the benefits are widely shared while the costs are reduced and not pushed onto the most vulnerable communities? In the coming years, this issue will become more visible. AI and data center expansion are likely to increase electricity demand in many regions. Supply chains for chips and batteries will remain geopolitically sensitive. And societies will continue debating how much connectivity is healthy and how much is extractive. The hidden cost is becoming harder to hide, and understanding it is the first step to shaping a digital future that is not only smarter, but also more sustainable, more resilient, and more human. If this video helped you understand the world a little better, give it a like and consider subscribing to World Explained. Your support helps us continue creating clear and neutral analyses of complex global issues. Thanks for watching, and see you next time.